So the basic loop we wrote in the previous section to run our node scripts more or less works, and we've definitely used it on a lot of our production projects even and everything. But it would be nice if we could have a slightly more advanced or slightly smarter way of keeping our scripts running, especially if we're doing some cutting edge stuff which may or may not be pushing some boundaries in Node and, might cause have some memory issues or otherwise be, really pushing limits of the machine and occasionally running into trouble. We'd like to have a slightly more advanced way of doing things. So again, our basic formula here is while true do node run, some sort of script, and then we say done, and it loops through this. It would be nice, however, if we said, not only should we restart if the node thing has crashed, but it would also be somehow nice to say, if node using too much memory, kill it. JavaScript is a garbage collected language and does do its own memory management, but there are some definitely some edge cases where you can use up too much system memory and run into trouble, or it'll just actively just consume way too much. And, sometimes the best thing to do is to just terminate it and restart it and sort of give it a fresh pool of memory to work with. So it would be nice if we could have that. And then it would also be nice if we could, oops, I guess that's not valid, shell script. It would also be nice if there was some way for us to sort of detect, it's crashing way too much. We just want to stop trying. Like, it's crashing a couple times a day or even a couple times an hour. That should be okay. But, if it's just crashing 10 times a minute or something, it would be really probably nice if we could tell our script, okay, just stop it, send an email to somebody because there's something seriously wrong. So let's look at how we would go about accomplishing these two tasks. First of all, finding the process ID of the last executed node script so we can do some greater analysis on it, and then how we might actually choose to do some of that analysis. So to actually figure out the process ID of the last executed node script, we're going to use a command available on Macs and most Unix machines, including all the Linuxes I've ever used, called pgrep. And we'll give it the -n flag, which says run the most recently, just give me the PID of the one most recently run instance of this program. And then the -f says match this program and its command arguments. So for example, I might say match node script name.js, and that says look through the sort of list of running processes and their arguments and find anything that starts with node script name.js, and then just return me the one most recent instance we have of that. So for example, let's say node, say while true do node simple.js done. Great, so let's simple.js like that. And you'll see that's returning the process ID of the latest running node script there, 5991. Okay? So that's the first part of it. We now how to know, and this is kind of important that we only get the most recent one, because sometimes, as we'll see in a section a little later on, if I have multiple cores or multiple processors, I might actually be running a number of different node processes all running the same script. Okay, so we have that information, so now what I'd like to do is I'd like to detect how much memory it's using. And for that I'm going to use the ps command, which shows me sort of all running processes. And I'm going to pass the flag wux, which gives me a ton of information, and then I'm going to pass in the process ID. And, oops, I'm not running the latest node anymore, so this is going to be a little tricky. So let's kill -1%1. Let's change this to run for, I don't know, 20 seconds instead of just 2. And so then let's run, and let's actually change the timeout to be a little less likely to. Let's say 1 in 10. So now I should be able to say, there. So now I can get the latest process ID. So now I should be able to say 6027, And this gives me a bunch of information about the process, including the actual command. And what I'm particularly interested right now is the resident memory size. So what I would like to do is I would like to somehow in a bash variable, node memory, how do I get just that value? And the way we're going to do that is we're going to do a bunch of little shell trickery using a command called awk, or AWK. And so what I'm going to do is I'm going to say pswx 6027, and then I'm going to pipe that through awk, and first skip the first row because I don't actually care about this sort of header output. Then I'm going to pipe that again through another awk program, and this program is going to print out the sixth column. So this is 1, 2, 3, 4, 5, 6. And now you'll see I can find the total memory that the currently running node process is executing. So with this information, the sort of process ID of the most recently started node, and then the amount of memory that that node process is running, I've actually gone ahead and written a little script here called Node Ninja Runner. And basically at the core of it is a while true loop like we had before. And what it does is it sleeps and it pauses for a few seconds at a time. And then what it does is it finds the process ID of the last node, and it assumes it doesn't need to restart it. Now, if it finds out that there is no node running with that script, then it says, yes, I definitely need to restart. If there is a node running, then what I do is I'm going to check for memory usage, and I'm going to say if the memory usage is greater than the parameter that the user passed to our script, I'm going to restart it, and that'll also force a restart. So then the other thing I'm going to do here is I'm going to add some logic that says if you've been restarting too much, then I'm going to start complaining and eventually just refuse to do so. So this is sort of the core of our script. I have actually gone ahead and added a bunch of other stuff here to sort of try and detect where things are, and I've actually added some fun stuff to make it work with colors and everything. But I've put all this in the GitHub for these live lessons, so you can definitely work through it and play with it. But let's show you it in operations here. You can say node. If I just run it without any arguments, you'll see it says what's the maximum memory, and then how many crashes in how many minutes am I willing to tolerate. So let's say sh node ninja runner. This can't take more than 15 megabytes, and I'm not willing to tolerate more than 10 crashes in 1 minute, and then I'll run simple like that. And then you'll see here just oopsie, but no, let's Emacs simple. Now it's definitely running not frequently enough. So simple.js, yep. Let's go back to 2 seconds and 0.1 in 4 chance of crashing. All right, so let's run our Node Ninja Runner again. And you'll see it's still processing the requests, it's crashing. And you'll see here it's figured out that it's crashed, so it's just going to go ahead and restart it. And so this thing is always keeping track, and if we're bad enough with our probabilities and we do crash 10 times in 1 minute, this Node Ninja Runner is going to say, you know what, this thing's crashing way too much. I'm just going to refuse to do that. So that's a pretty cool way of doing things. This is sort of a more extreme deployment scenario. I just wanted to show it to you, to show you we saw the basic in the last one. We saw a pretty here, and now here we're seeing a pretty robust and advanced one. You're free to pick whatever you want in the middle or something. Feel free to study the code for this one here in the GitHub and play around with it, and decide what works best for you. So that's our sort of more advanced deployment here on Mac and Unix-like machines, and then let's take a look now and also see how we would do that on Windows.